What's up, everybody? Welcome to TeslaFix. Today we have a special episode about the Starship launch, of course, because we've seen in the German media as well as in the American media, oh my God, Tesla failed big time. The Starship exploded, totally miss. But let's see if it really was a miss. And for that, we also have a very special person to interview today. And let's see who it is after the intro.
Welcome to TeslaFix. Make sure to subscribe and like this episode.
So Scott Walter is here again, of course. If we talk about the Starship, we have to have him on as an aerospace engineer by education and going through everything. So Scott, how was it that you've seen the Starship launch? Do you think it was a miss, or what's your opinion on that?
I call it a successful failure, because all along the payload was data, just like the first test flight. And there were so many successes and problems that they had in the first flight that we see are no longer a problem. And then we're just being able to see that there's a couple others, but that's the expectation. You're doing something that they had not done before. Yes, hot staging's been done before in both the Soviet program and the Russian program and the American program. But it's the first time that SpaceX has done it. And all things they learn by trying, and then they get it right the second or third time. So if we look right now, that with the Falcon 9, they've had, I think, 245 successful landings of the Falcon 9 rocket since the first successful landing in 2015. But you go back before that, and they had all kinds of failures. All kinds of they missed the target, crashing into the drone ship, everything else. There was a lot of them, and everyone kept on saying they'll never be able to do it. They'll never be able to do it. And once they get it right, here we are, 245 successful landings later. It is just crazy. Insane that they can do that. So I'm not worried about that. And we can go through what were all the points of success along there. And I guess the only other thing to kind of point out is, like, the reason why my handle is going ballistic is because that's a reference to rocketry and the idea that, when rockets go up, and once you've stopped thrusting, you are now going on that arc, which is called a ballistic arc, or going ballistic. Mm-hmm. It can also mean someone who rants a lot and gets angry. So it's just kind of like a nice little double entendre there.
Yeah, so absolutely crazy. But how do you view it? I mean, you've already said that you see it as a success, and it's interesting to see how maybe also with the comments that Elon did before, and with the controversies stirred up right now in this conflict we are witnessing globally. And now with that, I think also the Starship launch kind of is skewed, and all the headlines that I've seen, many people seen, were a little bit outrageous to say that it was a miss, because, like you said, data was the big thing.
Data was that, and trust me, Wernher von Braun was not successful with the V2 on the first try. There were a lot of attempts, everything else. That is not only the nature of rocketry, it's just the nature of engineering and everything else. It's the nature of learning to ride a bicycle. How many times do you fall down off your bicycle before you figure out how to actually master it and do everything else? So mastery comes with failure. If you are not failing, then neither are you succeeding. That's really what it comes down to. Mm-hmm. So you need to push the envelope a lot. There's this balance between being risk averse, which NASA is extremely risk averse, which is why the program is really slow, to the Silicon Valley mentality, which is, basically fail fast. You try something and try to get the data right away. And history is absolutely littered with examples of perseverance and people who didn't give up and finally were able to get it because they kept trying and trying. And one of the most classic examples is, of course, Thomas Edison, who had like over 1,000 unsuccessful attempts at coming up with the right set of filament for the light bulb. And then they finally got it. And of course, the press at that time said, interviewed him in essence, so what does it feel like to fail 1,000 times? It's like, it's like those were not failures. That was like, he said, the light bulb was an invention that required 1,000 steps, so the idea was that there's some material out there that will glow and should last long enough. So yes, Edison did not invent the light bulb, just like Elon Musk did not invent the rocket. What Edison invented was the first practical light bulb, meaning a light bulb that would last long enough before it burned out. So light bulbs before then just lasted a few seconds and then a few minutes or something like that. But do you really want to keep replacing your light bulb like every 5 minutes or something like that? I mean, it's like candles would at least burn for a couple hours before you had to replace the candle. So, that was the whole idea. And so Elon's doing the same thing with rockets, is that, yes, rockets have been invented. The thing is, they're expendable. They're not something that you would consider practical yet. And what we're trying to do is invent the world's first practical rocket, one which is fully reusable. And yes, the Falcon 9 is a very practical rocket, but it's still not 100% reusable. That second stage is thrown away every time. It's expendable. So think about it. The second stage has got a Merlin engine on there, and it has the tanks, the avionics, everything else. And they're getting close to 100 launches this year. They've thrown away 100 second stages. That means they had to produce 2 second stages a week to keep up that cadence. And, just look at the second stage of the Falcon. You think that's something that's easy to put together? That's a bit costly. So you want to come up with a way of having full reusability. They're getting closer and closer. And the only way to do it is to come up with this kind of architecture, which is what the Starship was all about. Plus, it will be able to handle like any size payload, not just from the standpoint of mass, but from the standpoint of volume. So the Falcon 9 and the Falcon Heavy have the payload capability for certain payloads, but the fairing isn't quite big enough. So they need to get something that has a bit more volume for that. And it's going to be, you'll always be able to come up with something that's, much bigger than the rocket you would like to have, because that's just the nature of everything. Like, your computer, as soon as you get more memory, next thing you know, boop, it's full. And it's like, wow, it's 10 times more than I had a year ago, and it's already full. So we tend to utilize something like that we have. So how do we get there? And what have been the successes? And, what was the quote failure that we saw yesterday? And I think there were way more successes, and the failures were just unknowns that they were trying to find out to say, is this going to work or not? And now we're going to know. It's just like Edison. He tried one thing and it's like, that didn't last very long. Move on to the next one.
Yeah, that's also with the scientific method, of course. You have
That
to
is it.
test it. And come on, I mean, how can you test a rocket? Just you have to launch it, and then it might explode if it has a failure. Then you have the data. Oh, this failed, and then okay, we have to do this part better, or here I don't know, there was a spill, and we didn't see that coming, and it's trial and error. Of course, it's an expensive trial and error, but a necessary one, like you said. And I have this compilation here of I wanted to show. I've put it up in between, but yeah, it's totally. You need it. You need stuff like this to happen. Yeah.
All the time. Yeah. And, silly little things like, just ran out of oxygen, or they didn't have enough hydraulic pressure. The hydraulic pressure ran out. Just on and on. Tweaks to the control system they had to do. Now, the landing is very tricky because they have to do what is almost like this hover. They can't hover. They actually have to come down and exactly stop at that point, because the thrust to weight ratio, even down like to one engine, is too much. So they're slowing down, and they cannot sit there and be able to throttle the engine enough just to be able to softly come on down. So it is rather remarkable that they can do that at all. And the fact that they are doing it successfully on ships in the middle of the ocean, as well as on land, and do it 245 times. And just make it look easy is just remarkable. So yeah, you never give up. Engineering is all about testing and failure. Material science is like all about testing materials until they fail to find out what it is, so you can get the data points to be able to move ahead. And again, Edison's failures were basically chronicling all the materials and what their properties were. So while some of those materials were not used in the light bulb, they were used in later inventions because they had properties they discovered along the way that was useful. And so that is the nature of engineering, is that without information, you can't model anything, and you can't figure out how to move forward. So it's all about getting the data right. And if we want, we can go through the litany of all the things that failed in the first launch that were no problems in this one.
Yeah, we couldn't move forward with discovering things, actually. Yeah, it's interesting. I mean, I have also here a video of the launch here that was filmed by a private person. I mean, it was
that was actually in Mexico. Yeah,
in Mexico. Mm-hmm. And
look at that plume. Look at the length of that plume and compare it to the rocket.
And also like you can really see how heavy it is, because it is heavy. It needs so much thrust to get up there. That's was for me
Yes.
the biggest differentiating factor to see when I compared it, because I'm not in the field, of course. That's why I'm looking at it like a just like a observer with no knowledge behind it. So but that's something I could have seen, and it was remarkable to see how much load and how big it actually is. It's huge. This thing is really huge. It's like I don't know, a cruise ship you shoot in space, more or less.
It's incredible. It's much taller than the Falcon 9, yet it was able to clear its tower faster than the Falcon 9 does. So it really jumped off that pad pretty quick for something of that size. And of course, the first thing, there was not the concrete tornado like there was the last time. So the pad came through really well. You did not see debris or rocks or anything being thrown all over the place. It also made it off the pad with all engines running. So that was the first thing that everyone assumed, that at least one engine out was going to happen. Because even in the static fires, they would have like an engine out or a couple that would. So all of them made it through, which was remarkable. And then it was like, well, they'll probably start to fail on the way up like they did last time. Nope. They made it all the way up to the hot staging, all the way. And then we're hearing his call outs, nominal trajectory, all systems nominal the whole way. So the last time it was way underpowered. It was probably, about 50% of where we're supposed to be at any point in time. And I'm eventually going to go through this and get the numbers and try to plot it over a plot I made last time. I was showing exactly what the performance was, the acceleration profile of it. And I have a feeling this is going to be very different. You're going to see, wow, they went from here up to there. So they made a lot of changes. First, huge changes to the pad with the deluge system to mitigate that problem. And it worked great. And even the people that watched both launches, I've spoken to some people that were on the ground there. And they said in the first one, you could almost feel like an earthquake coming through. The ground was shaking. And this time it didn't, which meant that it actually absorbed a lot of that energy rather than going to the ground. And plus there wasn't like concrete that was being blasted apart, which would kind of create the sense of a tremor. They also said it wasn't as loud as the last time. So again, it's showing that the deluge system is picking up a lot of the acoustic energy and helping to dampen the sound. There was not really a noticeable dust cloud or anything like that. So it worked. The question is, did the pad itself survive? And I saw some pictures afterwards and I'm like, wait a minute, these cannot be the after pictures. These look like the before pictures. It was just remarkable. And again, some people that worked down there close said that, yeah, it came through with minor damage. It's like a few little things here and there that are like really easy to fix. And then they expect that probably tomorrow they'll get in there and they're going to start working to get the pad ready for the next booster static fire. So it's almost like there's like nothing that really has to be repaired. It's just like the normal kind of maintenance stuff. They're going to go in, check everything out, how it's going. And so they're moving ahead there. So stage 0 did fantastic. Absolutely no problem. And then we can look at stage 1. Yes.
Here's the pad. I just wanted to show that for 1 second. That's this deload system. Sadly, no video, but you can see how it's made here.
They call it like a
like.
big shower head. So it just sprays a lot of water out there into the plume as it's coming down to try to cool it down to prevent it from having, such, and it takes a lot of the acoustic energy out, because a lot of that energy goes into vaporizing the water into steam.
Yeah.
And to convert water to steam requires a lot of energy. And the idea is, and a lot of it's actually coming from acoustic energy. So that acoustic energy goes right into there, which is why you're not going to be hearing very much and why it quickly goes into steam. And so it works phenomenally well. There was question marks about whether it'd be able to do it with a vehicle of this power, and it did really quite well.
Yeah. Absolutely crazy what the inventions were, how they move forward. And you were referring that of course the launch was totally different than the last time when they also tested the boosters, and now with this launch and the hop they did and everything. So maybe you can go into detail what were the stages, so people understand in rocketry, when you build rockets, what are the stages, so people understand that this kind of launch, even if the rocket exploded afterwards, it didn't land, what type of success it is actually. Because first you test the boosters, then or the single parts, and then you go to launching the thing, and then
So it's basically, you know, the integrated test flight is what it is. So it's the first time they integrate the whole stack to get it fully integrated together to see whether everything works together. So the first testing is like you test the Raptor engines by themselves. And then when you're confident that they work well together, you start putting them together, because you are going to have a lot of resonance and every sort of other issues where one Raptor by itself might perform really well, but when you put them together as a group, there may be some sort of issues and you have no idea what that's going to be. So you've got to test. And that's why they have these static fires and everything else. We put them on there, see how it performs. And then if the data looks good, then we're confident we can go ahead and launch. And they decided that rather than just launching the booster by itself, which is, one possibility, they want to do it fully stacked. So that's why they wanted to put the Starship on top. Now, normally, with NASA in the past, when they do stuff like that, they're always a little bit nervous about putting it on there because the hardware they're putting is so expensive and they don't have another one to quickly replace it. They've got so many Starships around there. There's like and they have warehouses full of Raptor engines. So it's not like they have a supply chain problem with those things. What the problem they have is they can't actually test them fast enough, the speed that they would like to do. So while it's sort of, let's say sad to see this thing blow up and not be reused, it wasn't intended to be reused anyways. If it was a full success, they were going out into the Gulf and into the Pacific, and that would be it. They probably weren't going to recover it or even attempt to, and definitely not to attempt to reuse, because they just needed to find out, is the hardware flight proven? Is it going to work? What are going to be the failure points? And now we know what some of the failure points are. The failure points don't seem to be the Raptor engines. They performed really well on the way up. Hot staging the staging itself seems to have been successful. It worked. But the question is, did using hot staging then result in problems later on? Mm-hmm. So everyone knows what's going on with the hot staging is that the second stage engines are lighting up while it's still connected to the first stage. Usually you don't do that. You separate the two, you make sure there's a safe distance between them, and then you light up the second stage, and then everything will be out. Now you'd want to do that for two reasons. One, you don't want to damage the booster, because the booster is going to be in the direct line of sight of that engine plume. It's going to be taking all the heat and pressure and everything else from that. So that could cause damage to it, especially if you want it to be reusable. Then there's the other possibility that there could be blowback and everything else from doing that could actually impact and hurt the second stage. So those are the two dangers. So why do you go ahead and do something like hot staging? Two reasons. One of them is to mitigate what they call gravity losses. So as long as you're not thrusting, so if you're not producing at least 1 G of acceleration or thrust, you're going to start decelerating and losing velocity, which you do not want to do. And as soon as you lose that velocity, you have to make it back up. So that means all the fuel that you're spending to get up to some speed, suddenly you're going back down, and now you have to make it up again in order to get up to where you want to go. So that's a loss. And if you can continue that, it makes it a lot easier to achieve orbital velocity. And that's why they want to do this trick. The other is this thing called propellant settling. And that as soon as you're weightless, and I think everyone will have an example. If you've ever been on like a trampoline or an elevator, like when the elevator quickly goes down, you notice that they talk about how suddenly my stomach is in my throat, this feeling that all your stomach contents want to move up like that. Well, that's what's happening with a rocket. As soon as the thrusting stops, the propellant unsettles, which means it just starts moving around inside the tank. And you got to remember, the tank is near empty at this point. So so the part that's empty in your container, quote, empty, is what's called ullage. And then the other part is sort of what's filled. And the ullage isn't necessarily empty in the sense that it's a vacuum. Something else has to replace this fluid that's gone. And so you fill it with some sort of gas. And usually there's an ullage gas, which would be like helium, which is what they use in the Falcon 9. And that fills up the empty space and acts as a pressurant, because it's very important that you have to maintain pressure throughout the tank or the tank will collapse on itself. The same thing with a beer can. You take a beer can, and when the beer can is full, it's very difficult to crush because it's filled with a fluid, and the fluid is incompressible and it won't crush. But once you empty the contents of that, you go and you can crush the beer can like that really, really easily. So it is, in a sense, if you take the super heavy booster and you were to shrink it down to the same size as a beer can to scale, the thickness of the walls of that booster will be thinner than the thickness of the walls in your beer can.
Okay.
Yes.
Wow.
And so
to save weight and
yes, just to save weight. Now it's something like about 4 millimeters is the actual thickness, which is, think about it, that given the size of it, it's only 4 millimeters and your beer can is already pretty thin. So you're getting thinner than that. Now, the reason why they can get away with it is that your beer can is made out of aluminum and this is made out of stainless steel, but still you have to make sure you have the pressurant in there. Otherwise it's going to collapse upon itself. So SpaceX has been trying to get rid of as many parts as possible. And the pressurant they are using in this case is actually the superheated gases of either the propellant, in this case, methane, or the oxygen that's used to cool the engines. They recycle it and bring it in and they pump it back into the top of the chamber. And so that will pressurize it because now you have this hot gas, which will kind of expand. The problem is that hot gas is coming in contact with like this really cold liquid down there. So you have an interface. And if you think about it, if you remember when they started out yesterday's live stream, you saw like that fog that was along the ground and everything. I mean, that's what happens when warm, moist air comes in contact with cold water, with a liquid, is that you end up getting this vapor layer. That basically means you're getting condensation. That means things are cooling down. So you've got a couple of things you're concerned with. One is the propellant settling. As soon as you go weightless, turn off the engines, the propellant is moving up in the void and is basically floating around in there. And you need to get it back down to the bottom because down at the bottom is where the intake valves are.
Yes.
And if it's not there, then there's nothing to be able to go in there. Plus you need to push it down with a propellant. The other problem is that you have this danger of ullage settling ullage collapse. And what the ullage collapse means that if I have a container where the lower part of the container is, let's say, has ice cold water in it, in the upper part of my bottle, I actually put a very warm gas in there.
Yeah.
And then I seal my bottle off. Okay. And now it's okay because the top of the bottle is still kind of warm, it's creating enough pressure for it to go out. If I then shake the bottle like that, suddenly that warm gas up there is going to chill and potentially precipitate out. In other words, condense. And that means a lot of the gas I had up there suddenly turned into liquid. And that knocks down the amount of pressure that you have, as well as the fact that now that warm gas is now very cold, and suddenly you can get the container to collapse. So that's what they call ullage collapse. And that's like one of the concerns and why you want to constantly thrust, because you do not get the propellant settling and you do not get ullage collapse. So with that long-winded explanation, what actually ended up happening at some point. So the hot staging worked pretty well. And you'll see that they had to create a ring in between the two stages. And that ring has these large vents in it. And those vents sort of allowed the exhaust plume from the second stage to vent out through there. Otherwise, you would get an overpressure and everything would explode. You have no choice but to do that. And they had to hold it on for a certain amount of time because it gets really tricky. You've got 33 Raptors and it's getting close to empty, that tank. And then they shut it down to only 3 Raptors and 3 Raptors at 50%, because that's about, you can go a little bit lower on the deep throttle, but right around 50%. And that means the whole stack is still accelerating. And with it still accelerating, you do not get the propellant settling. You don't have to worry about that. Now you light up the second stage. And so it's happening there. And it's pushing back a little bit on the first stage, but it's not really, it's still connected. So it hasn't been released yet. But you have to wait till all 6 of those engines get up to adequate thrust, probably full thrust. And then at that point, you release the stack. And that means the second stage is going to pop away. Okay, so the first stage has been responsible for accelerating the whole stack. So it's still got enough thrust, it's accelerating the whole stack. And at this point, the heaviest part of that stack is probably the second stage because it's got all of its fuel in there. And the first stage is just about empty. So as soon as you pop back, and there's that possibility that you get like a little bit of an overpressure, like anything. So it's going to pop out like a champagne cork along with its own thrust. And you hope that it continues to accelerate away fast enough, because now you get this first stage that suddenly is like near empty, and you have these things here that were lifting something really heavy, now suddenly that's going to want to accelerate. So that booster is going to start to accelerate faster now. And you've got to make sure that the second stage is moving faster away, accelerating faster away. So you've got to, and that's why they had to have all 6 engines. They couldn't say, well, let's just separate with 3 engines to make it a little bit easier, and we'll turn on the other ones a little bit later. It's like, nope, that's what it says to be able to do it. Now, there was this problem with what you're talking about here with the blowback. So what's going to happen is that when that thing kind of pops out and it releases, there's going to be a sudden force on the first stage to push it back down. And it looks like they may not have had quite enough thrust. So Scott Manley went through and he thinks he detected, I'm going to try to look at it as well, that it appears that the speed of the booster, it actually slowed down faster than you would have with gravity. So he suspects that what happened is you get a little bit of ullage collapse potentially, or at least propellant unsettling when that happened. So it sort of pushed down momentarily for a very short period of time. The question was like, was that enough to kind of disrupt what was going on in there?
Yeah.
And then they needed to light up all of the engines. Oh, not all of them, all the inner engines. So you've got an outer ring of engines, and those cannot gimbal. But everything interior can gimbal. And with that, they have like a lot of control. And they do not have any reaction control system on the booster to be able to reorient it. The whole idea is they're trying to get rid of all of the extra mass that they can, and unnecessary parts. See what you can do. So they said, well, we actually have rocket engines on there that we can use to flip it around, and we'll just go ahead and use those. But we're going to have to gimbal them. And in order to, I guess, do the maneuver quick enough, they needed to light up all the engines. And then you see they couldn't get them all to light up. So what I suspect happened is that, if you take, and somewhere, I wasn't prepared here, I should have got a bottle of water, that, if you take a bottle of water and you hold it this way, everything is going to be nice and all right. But if you kind of turn it horizontally, suddenly it's settling this way, isn't it? So you can imagine that one part of your bottle of water is submerged and the other part of the bottom is not. And each of those has got an intake around there for all of them. So that means some of them were literally starved. It's like, hey, there's nothing for us to consume here. And the others were like happily getting whatever they needed going out through there. So that might explain a reason why all those engines out were kind of on the same side. And it seems to have knocked out one of the center engines as well, which is like, well, wait a minute, it was already firing all right. So there shouldn't be any problem with a startup. It probably means it was starved. The other thing you have to be careful of is that, again, why with the propellant settling or unsettling, when it goes up, it means the stuff below it gets kind of filled in with the gas below it.
Yeah.
And if that's at the intakes, it gets sucked into the intake. And it's like you don't want bubbles in your gasoline flow and in your internal combustion engine. That's not good. And it's also not good for a rocket. So if you are ingesting gas rather than fluid coming on in there, and you have these turbines that are spinning really fast, and suddenly this bubble comes through there, they overspin like that. And when that happens, then your power head decides to rud, and then things aren't good after that. So that probably is a good explanation of what happened around there and why things were not going well. Now, that did not cause the destruction of the first engine, of the first stage. It was probably the automatic flight termination system, or sometimes it's called the FTS. It does not appear that SpaceX intentionally said, okay, we're going to self-destruct it right now and push a button in mission control. It was a decision made on there because it probably detected something was going wrong with the vehicle at that point, and it just went. And you can see how quickly it went. And I'm pretty sure, and a lot of other people are pretty sure, it was probably the FTS that did it, because you can see one frame where everything is okay. And then if you just go through one frame at a time, and 30 seconds later, you will see a little plume right in the middle, which is where the FTS would be, that probably triggered it. And then one frame later, you see it get much bigger. And then one more frame after that, it's a big sphere. It's a fireball. So it seems to be about where you would have the FTS system set there in order to make the charge between the bulkheads to have it go. The other possibility is that there's a lot of external plumbing that goes up and down the ship for like the autonomous pressurization, that maybe one of those somehow failed or something like that. What they call like the downcomers that are along there could maybe have had some sort of failure going on there for other reasons. But I suspect that it was actually FTS that went ahead and did it, because it just blew too quickly. A lot of times you would see like some other trail or something going on there while it's waiting to get kind of enough to get that big bang coming out of it.
Yeah.
But yeah, it looked like it was that. So that's
Okay.
the first stage. And then I'll let you jump in here for a second.
Yeah. No,
And
no
actually,
worries.
I put a tweet out there with those images. I should go
Okay,
ahead
I'm gonna.
and find that shows that was out there yesterday. So if you go to my profile and
Yeah,
scroll
I'm gonna do
down,
that.
yeah, past all my snark tweeting, you might find or snark posting. Sorry, that's supposed to be the proper term. You may end up finding something there.
Yeah, I can see it. The 4
Yep.
frames, right?
4 frames exactly.
Yes, I'm gonna pull them up. And yeah, but interesting how this unfolded with like you explained it, because this clears clears many things up actually, because yeah, people were wondering what was happening, and also the press
Yeah,
seemed not
and
to
more,
get what was happening.
more than likely, it's just a couple of kinks they have to get out of the whole burn back kind of situation. How they're going to manage that, and the
Yeah.
different timings, and the fact that propellant and everything's going to settle a particular way. So everything is okay. It's not clear whether there's something going bad towards the tail end of the booster at that point. It's there's something that's a bit bright there, but it doesn't seem to be a problem. And now you see the next frame in the upper right there, and that you can see there's some sort of explosion happening right in the middle of the booster,
Here,
unrelated to anything towards the tail end.
yeah, exactly.
And then the next frame after that, you see it starts to consume it a bit more. And then the next frame. So those are like a 30th of a second apart.
Yeah.
So that's pretty quick. Like it goes from nothing there to completely consumed, and then that fireball got even bigger.
Yeah, absolutely. Okay, interesting to see, because it really is from the middle. You can really see
Yeah.
that. And
Yep.
if the explosion would have happened from the bottom, right? If
Yeah. See, our first suspicion was like, well, maybe there's something with a hot staging, because the bottom is actually towards the top. So where you see the bright part, that is where the engines are. And then the dark part to the left of those, that is the top of the booster where the hot staging happened. That's where the ring is. And that's where a lot of the concern would have been. It's like, well, wait a minute. Did that heat shielding survive? Did it somehow not instantaneously cause destruction, but did was something still very warm and soft and is slowly failing? But the failure point is not at the top of the booster. So it survived, definitely, the hot staging. So it did not damage the booster. We think, we wouldn't know until it actually attempted to land. And then you find out there's something wrong with the grid fins or some other sort of thing. But that is not the reason that it exploded. The reason it exploded is that something happening on the other side where the engines are, and more than likely a lot to do with the propellant sloshing around and the settling the propellant. And I don't think you had ullage collapse, because, ullage collapse would just cause the can to come in on itself. So it seemed like they were able to handle that all right. But the flight termination system was activated to definitely take it down.
Okay, and did they see that in the data, or we didn't have reports? Right.
We haven't had any reports on that.
Okay.
There's been some people that are pretty well informed. Really, let's just call it informed speculation that seems to be that way. There's very little pushback from anyone thinking it wasn't done that way. And I've heard like some things through grapevines that it probably was the flight termination system. Now we know for sure the second stage, the FTS, was used, because they said so on the live stream. Yeah, that it just suddenly terminated like that, and
and then
we don't know why.
Yeah, and when so it was disengaged. The second stage started to go off, and then the bottom part exploded, and
the bottom so the bottom part got far enough away. And I mean, see, this is a good question. Is like, that was a pretty big explosion, and was the second stage at that point far enough away that it didn't feel any impact? There wasn't like a projectile or something that just happened to strike it. I think it was probably far enough away at that point, but they'll be looking at that really, really closely. But there's got to be a lot of suspicion that something to do with the hot staging compromised something in the Starship that caused it to fail later on. Now, it looks like it was pretty much nominal the whole way. So everything was lit up, but they didn't have any engines suddenly go out. Have to look at the telemetry data to see whether there was anything kind of going funny with the acceleration. But the acceleration looked pretty good. And the last time, when you looked at the fluid levels that they had for CO2 and oxygen, they were like doing some really funny things. One of them suddenly like fell really fast where the other one didn't. They seem to be pretty consistent, though. Scott Manley thinks something happened with the LOX, that the LOX was a little bit higher, the indicator, than the methane most of the way through. And then suddenly it kind of caught up really quickly, meaning that he thinks that suddenly around a certain period, I think it was like 7 minutes into the launch, it was consuming liquid oxygen faster than it should have. And when we look at it, it was burning really brightly going up there, and you weren't seeing any plume because it was just like this typical kind of, methane kind of flame. You're not going to see anything when it gets up there. You're just going to see these bright dots. And then suddenly you were beginning to see something that was like, well, that looks kind of like, the classic space jellyfish, but should we be seeing it? And it's also a bit unsymmetric. So if you really were getting a plume, everything should be, and it was like a little bit off to one side. So something didn't quite look right there. And that could have been an indication that there was a power head failing or some sort of leak where suddenly, more oxygen was coming through. Or again, a term is they call it being engine rich. So parts of the engine may have been going through, which could have been, the nozzle or something like that was suddenly getting too hot because something was failing. And, that could be related to all sorts of things. One is that if something was failing, that the oxygen was now leaking out, and the oxygen is part of your coolant loop. And, now something is getting a bit warm, which means, parts of the engine are just going to start going in the exhaust, and you begin to see that. But it looked like it wasn't getting anywhere near orbital velocity. So you're looking down and it's like, wow, it's just not getting there. And I was like, don't worry. That's the way the rocket equation goes, is that it seems like you're not making any progress. And then sure enough, it just started like dialing up really quickly. You could just see the numbers getting very, very, very close. And I think it had to get to like 27,000 kilometers per hour. And it was like at, down around 17 for a while. It's like, is it getting anywhere? And it just sort of climbed really quick past the 20s, was heading right on up there. And made it to, I think, right around 24,000. And then you didn't see anything more. And then you saw the engine lights go out, and it's like, oh, okay. I mean, that might've been close enough, because I was trying to remember what it is in kilometers per hour. And remember, this is suborbital, not to, so I thought maybe they had achieved their goal and it shut down, but it appears what happened at that point, because then you could see some other puffs just before that happened. That's when the flight termination system went off. So it didn't quite achieve, the proper SECO. That it was a forced SECO at that point. It still had a couple more seconds, but it was really close. It seemed like it was very close. So it almost seemed like there was a shut off and failure, but it looks like it was the other way around, that it was almost ready to get to shutdown, or brenchless, as they would say. And then boom, it went. And it could have been, again, because there was some failure going on with one of the engines.
Yeah.
And they need to make sure it comes down in little pieces, because they were flying, over the Caribbean and some small islands and stuff like that. There's still some populated areas. You have to be careful. And the idea of the Starship just like deciding to fall out of the sky in one single piece was, something you don't want. So it didn't just boom, and you get a lot of these smaller pieces, and hopefully all the chunks would burn up on the way down at that point and not really cause any danger. Except to maybe some sharks. I'm sure a couple of sharks might have been in danger.
Yeah,
but if anyone doesn't understand that reference, it's because evidently the Fish and Wildlife Service was really concerned that Starship might kill some sharks. So,
okay. Yeah, but hopefully not. But interesting that you went through the whole phases and the speculations that are in the science community now, and also in the every nerd and geek from the aerospace side will look at this footage over and over again to figure stuff out. Yeah,
but there was one piece of concern that I kind of had that may not. It's been allayed, I think, by Jonathan McDowell, is because they were so close to orbital velocity at that point. I was a bit concerned, like, oh my goodness, when you get an explosion like that, and especially if it's a really strong explosion, there's possible that some of those pieces will actually make it into orbit. Yeah, and then I was like, oh, he just added some space junk here. And he did some quick rough calculations, and he didn't feel that there's none of us going to make it orbital, that some might kind of go up, but they still won't have enough, and their trajectories are going to be such that they're going to pretty much come right back down. And then I guess NOAA or radar picked up a lot of this. The weather radar actually picked up a lot of the debris field and everything, and they could see like all sorts of stuff. And I think there were some people down in Puerto Rico that also shot some video footage that you can see the streaks kind of coming through that, you know, kind of reminiscent of Columbia when Columbia broke apart. You would see these sort of pieces coming on through there. I don't know if anyone's collected any yet, where they will, but there's that. So yeah, there's probably something related to the hot stage. I mean, they'll find out whether it was that or whether there was something fundamentally wrong with Starship that, you know, it was that problem was going to happen. But there is one problem that they are going to have to work on. That is a lot of the heat tiles were falling off on the way up. You could already see that. So they haven't been tested on reentry right now. They're still kind of falling off. So that's my biggest concern is how they keep those things on, because that was always a problem with the shuttle. Seems to still be a problem with Starship. And they're just going to have to find, and I just don't know whether tiles is the best way. I just feel like, isn't it like just something you can just kind of spray on? That'll be really kind of cool. But, you know, it's just there, you know, it's like, we're just so used to coating things with stuff, you know, it's like, but you know, you need some kind of special material to be able to do it, that because of different material properties and expansion and everything else, it's not that easy. So yeah, that's where we're at. And again, like I say, it's definitely a successful failure. And it looks good that there won't be such a long delay for the next one. So some people speculated it could be the next one could be before the end of the year, and the meaning this year, not the next year. That is like probably the best case. But, you know, the FAA put out a statement yesterday that, you know, there has to be an investigation because the you know, blah, 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 even though it's like the expectation this is going to happen. But because we didn't have a concrete tornado and everything else, a lot of the environmental concerns probably will be allayed and that you won't have that kind of delay. So there will be the investigation. The question is it going to be like a 60 or 90 day kind of thing where they can do it quicker than that? Kind of the pressure that the FAA has been getting, let's say from Congress and others and from NASA to say, hey, look, do you want us to get to the moon? Because the Starship program is vital for us to be able to do it, because we need the lander is going to be Starship. So they're going to want to push it ahead. I'm thinking that late January, early February was probably the earliest. They're going to be pushing everything, but we get an American holiday this week, the American Thanksgiving. Yeah. And we also have then the Christmas holidays and New Year's holidays. And it's pretty tough to try to get everything moving ahead. And so, yeah, I think probably January, February would be the next flight.
Okay. Yeah. We also the audience, I think, will look forward to it. Maybe you can write into the comments when you think the next Starship launch will be. Who knows? So
yeah. Well, as you know, I'm kind of hoping for February because you and I are going to be over on the same continent for a while.
Yeah, that's true. That's true. That would be awesome. Yeah.
So selfishly, I'm hoping it's February.
Yeah, of course, you have to go there and witness it yourself. Yeah. But super interesting stuff. And of course, for the context, why we need, you've also mentioned it, why do we need this big rocket, this Starship? Of course, this is the base for many missions that are going to come. This will be a revolutionary space vehicle that will be used for another moon landing, and also for, of course, going to Mars is the plan. What's the plan right now? Or they are on the way to that. So they did a test flight here that was successful. They gathered data. Maybe the tiles are a problem. Maybe also you've mentioned what the failure could be. So they're gonna. Now, the landing gear, we have to check that next. When those stages are happening and working, how does this thing land? Will it be catched by the arms, especially in the landing pack?
I think that's a couple years away before that happens. They'll be dunking a lot of them with soft landings in the ocean, of course, probably before they try capturing any one of them. And then the question is, which is going to be the best one to do the chopsticks with? Is it going to be the super heavy booster, or is it going to be Starship? And I'm suspecting they might go, you want to catch the super heavy booster first to see if that works. Yeah. Just because it's not doing that weird belly flop maneuver. And I think they will be able to have kind of more precision with that and everything to be able to bring it down. Whereas I'm just afraid that something happens to the belly flop maneuver and they don't come around and quick enough. And again, it's that whole problem of, well, that's why they have those header tanks. The header tanks are set up such that you don't have an ullage problem because they're full. They're full and they're pressurized. And so you don't have to worry about the orientation of it. So even though it does a belly flop, they should still be able to get it to light up. And they've shown that they can do it. But still, I'm like, oh, man, you're only like, 1,000 meters up and you do that trick. That's, oh boy. And I just have a feeling like the heavy booster will be coming in. And I think it's also able to do a hover if it needs to, because it has more than enough deep throttle and the thrust to mass and everything. They would be able to do that. So probably, that's my suspicion, that's what they would try to grab with it first. But the first couple are going to get dunked in the ocean. And there's no chance that they would put a drone out in the ocean to do it, because remember, no legs. If you don't have any legs, you got nothing to land on.
Yeah, that's true. It just lands on their boosters and they are crushed immediately and explode. Yeah, so interesting stuff here. Also, thank you for doing also the outlook. You've said what's going to be next, and are you hopeful? Maybe for the end of the episode, you can say, are you hopeful that it's going on? Because you've already mentioned that it was a success, but maybe you have can give a small outlook to the audience. That would be interesting.
I'm very. I mean, I was disappointed that it didn't hit some of the others, but the fact that it made it through hot staging, and again, I think SpaceX was tempering everyone's expectations by saying that, we are going to consider these to be successes. We haven't tried it. If we make it through that, that's okay, and everything else after that is a bonus. So if it makes it into orbit. And if they had it, because they wanted to actually test Starlink in orbit. So the disappointing thing is that we didn't have more footage like inside of what was going on, or some close-ups like you normally get on there. And they were going to be actually testing Starlink in orbit, which would have been really interesting. That the idea that they would be able to communicate with that, and they said that it was going to be important because there was a lot of places where there was no ground stations for communication.
Yeah.
And so disappointing we didn't get a chance to test that out, but we will eventually. And, disappointing that it wasn't able to, test the reentry and all that, see what was going on. And, remember, they went to a lot of effort to replace 3 actuators the night before. And the actuators weren't used because they didn't make it that far to do the soft landing in the Gulf. Yeah. So, but I mean, you live and learn and everything else. And again, you cannot succeed without it first failing.
Okay. Yeah, absolutely. So, fingers crossed that everything works forward. So everybody, please follow Scott on X. I would say that's the best platform to get a catch on. Of course, because all of this happened, he's going to be interviewed from the whole Tesla community, also the SpaceX community, I think. Also, look out for the cool spaces he's on all the time. So I'm going to link everything down below and also on the top right corner from your perspective. So yeah, thanks Scott for doing this again. And now I'm a little bit smarter now. So thank you very much. Also the audience has a lot of that. So yeah. Thanks very much.
Thank you,
Scott.
Yep.
And there's only one last thing to say to the audience. That's goodbye, everybody. Bye-bye.
Wasn't this episode awesome? Let's accelerate the pace of innovation by subscribing to TeslaFix. It is my absolute favorite channel on the whole interwebs.